Hello, hello. Let's see, how do I get the slides up there? Perfect. All right. For the longest time, this talk was named TBD until this morning, actually, when I sent in my slides. And it's now called the Onchain Data Frontier. So I'm Mats, co-founder and CTO of Dune. Hopefully you know what Dune is. I moved to Switzerland in 2023, and I'm super happy to be based here along with my co-founder. Our mission is to make crypto data accessible. We founded Dune in 2018. Today we have about 50 employees. We raised most of our money at the peak in 2021 when things got very crazy. We are a big web page in crypto, and we have a lot of people who essentially come to Dune and know us as like the front page of crypto. So millions of people come to Dune every month to understand on-chain activity, on-chain adoption, understand applications, tokens, all kinds of stuff on 93 blockchains, I think is the number today. Most people don't know that Dune is also crypto's data platform, and that hundreds of the apps that you use rely on Dune to get their data for their analytics and for their product stack. And recently, we've delved into building developer tools. So in November at DuneCon in Bangkok, we released Echo, which is a developer platform that provides very low latency access to sort of curated APIs for app builders. Today, we're going to talk about the status quo for on-chain data. We're going to cover how literally every single app in crypto gets data, how every analytics tool in crypto gets data, and then we're going to talk about what we think is next and what we're building. So the asterisk here is that we're at Ethereum Zurich, so obviously we're talking about EVM chains. On Dune, there's about 50 of them. In the world, there's probably several hundreds of interconnected L1s and L2s and L3s. And we're going to talk a little bit about the basics first, and then look at the frontier. So first, the way I think about the world is that blockchain nodes are really write-optimized databases. In order to build a new financial system to sustain the load of, I don't know, something like Visa or any popular app in the world, you have to optimize for writing. And so every single blockchain we use connects to a RPC node that's optimized to write quickly. And unfortunately, reading data is clunky, inefficient, and it's bolted on as an afterthought. The indexes that power the blockchain are there to power fast writes. And insofar you can read data from the blockchain, you have to read it sort of in the format that it exists on disk to support writes. So in the EVM world, we throw around JSON RPC a lot. JSON RPC is a technical term to describe a way for computers to interact. But in crypto, we mean a set of standard methods, API calls, that you can make to send or receive data. Virtually all data purposes in the EVM world are covered by 4 methods. So ETH call allows you to read data from an account. ETH get block by number gets you to get all the transactions and the block data from any given block. Get block receipts allows you to get the logs, so where things like events are emitted. And then you have the special snowflake, which is called debug trace block by number, which allows you to trace the execution and understand essentially what a transaction does. Calls contract A, calls contract B, calls contract C. This is virtually what the world relies on, these 4 methods. This is reading, if you want to read directly from the network. And that goes for sort of apps, and it goes for analytical tools as well. There's a caveat here that there's some like convenience methods for like filter logs or something like this if you're building an app. But generally speaking, like the data that you get out of these 4 methods is what you have to work with. So in the analytical world, there's providers like Dune that essentially expose data that's all derivative of these 4 methods. And the reason Dune exists, the reason other tools exist, is essentially because you cannot do an analytical query on top of a blockchain node. It's just not meant to do it. It supports point lookups by block number, and that's it. Dune and other tools allow you to count the number of DAUs on Uniswap that's traded more than $10,000 every day. This is just not possible if you connect to an RPC. But Dune and other tools sort of transform data, enrich data in order to provide something that's more useful. But the way we divide our data in Dune is like we have raw data, which is essentially the raw output of the latter three RPC methods that I showed you. We have decoded data, which is where we take the ABIs of smart contracts and we decode so that the data is no longer just arbitrary hex-encoded bytes. It's actually typed information that you can query. And then we have curated data. And this is where like 90% of the utility and queries that are run on Dune and other platforms are done at this layer. This is where you combine raw and decoded data with metadata such as token prices, token symbols, I don't know, all kinds of stuff to create things that a human can actually look at and answer questions from, like DEX trades, NFT mints, stuff like that. And it takes quite a bit of work to get to that point, actually. Just quickly glance over these data sets to show you what it looks like. So here we have an example of transactions on top and logs in the bottom. This is what you have to work with when you call these RPC methods. And it's all hex-encoded bytes. So it doesn't mean much to many people. You have to have some understanding of like the smart contract that you are calling or that's emitting these logs. That's where ABIs come in. Application binary interfaces allow you to take that binary data and convert it to numeric data, textual data, etc., addresses. I pulled a slide from our sales deck in here. So on Dune, you have like millions of smart contracts and events. And generally speaking, they're divided like this. So you have divided by within the Ethereum blockchain, you have Uniswap v3, you have every contract, and every contract has an event or a function call. And together across the universe, this is like 1.5 to 2 million like tables you can query on Dune. So it's a lot. But as I mentioned, curated data is where most of the magic happens for most people. And this is where you have to like combine a lot of sources. So for instance, you cannot just go to a Uniswap contract, look at its swap events, and know which tokens were swapped. It's just not possible. You need information from the factory contract. So at minimum, you need to join 2 decoded tables. Now, you probably also want to figure out what's the symbol, what's the name of these tokens, and so you need to get in more metadata. It's typically collected from ETH call, etc. So all in all, like data sort of flows in as a pyramid to produce this curated data. There's tons of challenges in this paradigm. So there are hundreds of EVM chains. The number keeps going up. And if you want to analyze an app, chances are you want to do it. If you want to analyze the revenue of Uniswap, you don't want to just do it on Ethereum. You want to cover all the markets. For curated data, like these categories, they spawn overnight. Like yesterday it was DEXs, tomorrow it's NFTs, and in a week it's I don't know, meme coins, etc. Like all that, like the utility of the data really lags. And even worse, like when all these smart contracts are deployed, we're at the mercy of developers that are emitting the necessary data in events. So in an analytical tool like Dune and others, you cannot really read the state of the blockchain at the time of a query. Like technically, you sort of can sort of build a tool that does that, but it's really clunky. In addition, you can't really easily create data here. So that's sort of the analytical world. As Dune has entered the data for apps space, I want to talk a little bit about that. So the way we think about it is that applications need to read data in a highly efficient manner. Like you need data specific to that app, which is what we call protocol data. So usually consists of event logs that are emitted from a set of smart contracts. But you also need access to data about the account that connects to the app. Token balances, for instance. You cannot go to the blockchain and say, give me all the tokens this account or this wallet has. There's no method for it. You have to rely on a provider, such as Dune, or build it yourself from scratch. Then you have asset data, and you have a myriad of providers such as CoinMarketCap, CoinGecko, DEX Screener, I don't know, who sort of in different ways try to provide you with token metadata, prices, URLs, etc. And all the apps need this. Like when you connect your wallet to Uniswap, they need your balance. They need to see your on-chain activity. They need the logo of USDC. They need the, I don't know, the price of USDC, etc. Like, there's a lot of data that comes together to create a good UX. Protocol data, so essentially like data that's local to a smart contract protocol. One or more smart contracts together form a protocol, generally used by an app. This field is sort of dominated by tools such as the Graph or Ponder, which are frameworks to create APIs. Generally speaking, it's all in TypeScript. And it works exactly the same as Dune and any other analytical tool. For every block, you call a number of RPC methods to get data, except in this paradigm, the user is allowed to filter, transform, do side effects such as calling other APIs, etc. And then the data is eventually inserted into a database, gives you an API on top. It's like either you use one of these tools or you build it yourself. Like, there's no functional decentralized application that connects directly to RPC. I remember we have the CEO of Aragon here. Aragon is one of the first decentralized applications I used, and it used to sync the blockchain into your local storage in the browser. So in order to vote in your DAO, you had to wait for your literal browser to catch up with the head of the chain. It could take days. So some of the challenges that app teams face are that indexing tool today is they're limited to events and function calls. So we're still at the mercy of emitting the right data in our events. And whenever we need to make changes to our index or to our database, typically you need to reprocess the entire blockchain. And since you have a dependency on these like write-optimized databases, the nodes, this is not very slow. Sorry, this is not very fast. It's very slow. And it could take weeks for you to get a new database that will power like Uniswap across multiple chains. And then, yeah, the fact that applications are deployed across many chains, you have to manage connections to n different RPC nodes, maybe multiple API keys, different payments. You need to map your contracts. Maybe your contract on chain A's version 0.01, on chain B it's 0.02. It's just a little bit of a mess. Okay, so that sets the stage for what I call the on-chain data frontier. What is the on-chain data frontier? Well, selfishly, it's what I'm building at Dune. And Adrian over there, who's also from Dune. So we believe that the future of on-chain data is one where you're no longer at the mercy of the sort of blockchain node that runs on Alchemy or QuickNode or in your dApp node. You're no longer at the mercy of the JSON RPC API. It allows you to go deeper. We believe that the future allows you to read the variables defined in smart contracts, any smart contracts, that you can write your data access logic in Solidity, work seamlessly across the hundreds of EVM chains, do backfills on these APIs in minutes, and get real-time APIs without any hassle. Might sound like a pipe dream, but we believe that the frontier of on-chain data exists in a paradigm known as simulation. So what is simulation? Essentially, simulation is replaying blocks, transactions, and in our case, inspecting them, pulling out data at different points of the execution, and doing this in a highly parallelizable environment. So we're essentially building a future where you can inject code into the EVM without deploying a contract on chain and paying gas for it. to emit any data point at any point during the execution. Not just an event, not just a function call. And we think it will revolutionize both analytical data that you'll use on Dune.com and application access to Onchain data, which we're building under the developer platform Echo. And essentially, the way we think about it is that we're building EVM Lambda functions. So if you're familiar with software development, you've heard of a Lambda popularized by AWS, essentially a piece of code that's called on some sort of trigger. It's just a simple little code, self-contained, that does one thing, and it's connected to some trigger. So at Dune, this is powered by an instrumented, hyper-parallelizable EVM that is incredibly fast and allows this flexible data access. And so essentially what we've done is we've taken the EVM, forked it, built our own, and injected code that allows us to inspect at any point given the execution what's going on. And this allows for flexibility that's not seen. And since we're not participating in a decentralized network, we can sort of get the performance that application developers need. So this is technology that we've acquired through a company called SmallXL. Adrian over here is one of the key software engineers of that company. You can try this on sim.io. It's live today for Ethereum, Base, and Worldchain, actually. So a little bit of a coincidence. And while you should expect major changes to sort of the UX or the UI of the product, like the core functionality of creating a Lambda and fetching data from any point during a smart contract's execution is still there. So it is quite simple, but also quite complex to explain how this works. But essentially, you write this self-contained piece of Solidity that will receive a context with data about the step in the transaction's execution. So it's similar to a debugger if you're a programmer. So you create essentially a little, I don't remember what it's called, but you say, I want to hook on this line, and I want to see all the data at this point in time. And then we allow you to transform all this data, read the state of the contract you're in, read the state of any other contract, and then emit the data. So you can do arbitrarily complicated things in here, and it's incredibly fast. But essentially, you also need to define your hook source. So if you're Uniswap and you want to act on Uniswap pairs, you could just select, I want this to run not just on this address, but any contract that implements the Uniswap pair API. And then you can define, do I want to call this piece of code when a log is emitted, when a function is called, when a variable changes? It's not possible today. And then after this, the data is submitted to our internal sort of Kafka topics, and you can essentially do whatever you want with it. Pipe it into your database, pipe it into our database, build an API on top of it, use WebSockets, etc. So what are we building with this technology? So what's next at the frontier? So on the one hand side, we believe that for analytical purposes, product analytics, to measure on-chain adoption as smart contract protocols become ever increasingly complicated, we need the technology to introspect and to instrument smart contracts. And so we'll allow you to do this and write the data back to Dune and allow you to join with the 2 million other tables there. So you don't have to create all the data you need. You could just augment the contract and go back and join it with DEX trades or any of the other curated data that you use on Dune. Secondly, this is new to Dune. We're sort of creating a framework on top of this that you work on in your own terminal, in your own editor. It's a local code-based workflow in a way that allows you to declaratively say, these are the contracts I care about, this is the data I want to pull, this is the destination of it, and you can deploy it to our backend from a local CLI or through GitHub Actions, sort of like framework-defined infrastructure, and you instantly have the APIs your protocol needs. fully managed, and real time. And then for us, we're also building out these account APIs, asset APIs that we talked about a few slides back, and we're obviously using this instrumented EVM to make these more powerful. Essentially, the way I think about this is you can run any piece of code on the blockchain without deploying a contract, without paying gas, without being at the mercy of a public or private variable. Yeah, so pretty excited about that. And if you want to chat about it, you can come find me after this. I'm also mats@dune.com, pretty simple. And yeah, thank you.